this complete? Yeah. So, forgot to record this. So, who else has some concerns? They are not able to progress because this is the time. Otherwise, we miss out on talking and.
Hello.
Yep.
Yeah. Sagar Lokunde here, sir.
Yeah. Yeah.
Yes. Actually, I'm telling you where I'm actually stuck. I have created Kubernetes single node cluster,
Right.
and also I have created MySQL database and persistent volume as well as persistent volume claim, and it worked because I generally delete the pod, and again the another replicas also work, and the same database also in that container. But problem is that but I don't understand how to integrate to Kubernetes Spring app with database. Means how we can manage that, how we should do actually.
Right. So your database is in the cluster.
Yes.
It's in the cluster. It will have a service endpoint created, right? You will be
Service.
creating a service from. So you watched the previous last week's video. You are pretty close. So what happens is that the pet clinic app is a Docker container which accepts an endpoint of MySQL server, a username and password.
Okay.
Right. That's how we have to construct the container image for for that pet clinic application.
Okay.
Right. You follow that README or follow some of the source code. It's pretty straightforward stuff. So there will be three environment variables, three arguments that we have to pass to the container.
Database actually it works. What we wanted that we should delete the pod and another pod also will create, and
Yeah.
the database we just want to have that database will have or not, that is also working, but how the both app and database it's integrate there, means I don't understand actually how to do it. Means I have lots of search on Google also, but I couldn't able to do that.
So basically, you will be creating a Docker image which will accept these three parameters, and then it will start. So if you want to try it out.
Docker image, already I have created Docker image.
Yes, so that Docker image should be constructed in this way that it accepts a username, a MySQL endpoint, and the username and password.
Okay. Then you mean to say that now another image I want to create?
Yeah, you have to make minor changes to that image that you have created so that it's accepting a MySQL profile, basically a MySQL endpoint.
Okay.
And you want to refer to some of the repositories that we demonstrated last week that should have all that information. It would be minor changes to your existing Docker image, Docker file. So you just make that change because this Docker, the pet clinic, you can start in 3 different modes. So you go through that README file. It will tell you that you can, the Docker image that for pet clinic can be started in 3 different modes using its local data.
Is there? Okay, continue.
And then it can accept an external URL of a MySQL server or a Postgre server as well.
Is there any way to, without changing in Docker image, we can manage?
You can manage, but like, for example, whatever you have built, it will not connect to an external database. You will still be able to browse the application, but it's basically using the MySQL available on that container itself.
Okay, yes.
Right. So if your pod dies, your database also dies with it and you can't recover it. right?
Okay. That single container, we want a single container Spring app also working as well as database also, right?
Yes.
Okay. Okay. I should do some work on that then.
Yes. You don't have to search online or anywhere else. You have to go through that README file, understand that it can be started in 3 different modes. Basically 2 modes. One is your using the local database inside the container itself, MySQL database of pet clinic container itself, in the in-memory database or whatever they call it in MySQL, in-memory database. But the other 2 options are using an external endpoint and using a Postgre endpoint.
Okay.
And last week we had demonstration of Postgres SQL as well and MySQL as well. So try to take a repository.
Uh, I couldn't understand that Sharath he did all that demonstration, but I couldn't understand which way he did, means that all the way I couldn't able to understand. So that's why I
Now, since you tried something, you will be able to follow that much. Like if you had not tried it last week, yes, you would not be able to follow that. But now, since you have spent some time, you know how this Docker image get built. You just take a look what 2 different additional lines that they have written, so that now instead of using an in-memory database, it's using an external database.
okay. Okay. Okay, thank you.
Yeah. Anybody else? I think we have explained to people, so it should be very similar to that. So create a cluster.
Sir, it's Sir Amanjit here.
Yeah, Manjit, can you come on camera? I can't. A lot of people are there, so I get.
Sir, I'm not. Hello.
Yeah, yeah.
Sir, I'm at a busy place market, so that is why I'm not turning on my camera right now.
Okay, okay. Please go ahead. Ask the question. What's the question?
Sir, my question is कि most of the companies they ask for multi-stage Docker file. So how can we convert this file into multi-stage Docker file?
You can convert this into multi-stage. So in the
So
first.
how do we do that, sir?
So in the first stage, you try to build the jar file, and in the second stage, you try to use that jar file that you have created in the project first, because it's a Java application. First stage, you will build that jar file, and then second stage, you will use that jar file and create a Docker image.
And then connect it to MySQL database.
Connect to MySQL database.
Okay. Sir, I just have another doubt. So like how in Terraform, it's irrespective of the way we write the code, the Terraform understands and create infrastructure. No matter if we put EC2 instance at the beginning or at the end while creating a VPC. So is it the same case in Dockerfile or we have to write it in a sequence only?
Dockerfile follows the sequence because Dockerfile is more of a interpreted thing. Like it will go step by step. Each step is a sort of layer. Terraform is a different, slightly different context here, because that has its own dependency checker and all that. It doesn't matter whether you are creating VPC after EC2 and all. If there are dependencies in between, it will be automatically be able to detect the dependencies and create those resources based on that. So if your EC2 code is saying that create EC2 in this VPC, this subnet, then it knows that VPC has to be created first, subnet has to be created second, and then EC2 has to be created. If you write your source code such that you are creating a VPC X, but your instance is going into a default VPC, then there is no correlation. Then it can create these resources either in parallel or based on what makes sense to Terraform. But if there is a logical dependency between them, then it will ensure that that those are created in that order. But Dockerfile is not that. Dockerfile follows a sequence.
All that, got it, sir.
So for example, you have a jar file or you want to build some file, you move those contents somewhere, then you build your pom.xml will have build instructions, or your whatever tool that you are using to build that. Then what do you want to do? That package is built. What do you do with that? You push it to some artifactory or whatever you do. So there are sequences in there. So that's a different way of in the Docker image.
So then the other thing is, I was looking at a YouTube video which was in which they were writing a Docker file to create a Java application itself, but they have used base image as Maven. When I tried the same, but I was like, I failed miserably at that.
So that's what, if for example, was it GitLab? They were using GitLab something?
No, they were using GitHub only, sir.
Okay. So to build, so see, basically these are different images available on public repository. If you are building a Java application and you need Maven, you take a base image that gives you that Maven version, and then you can build that any source code using that. So that's people do it all the time, depending upon, they will select a right base image depending upon what actions you are going to perform in that. It's a sequential thing. If you sort out the dependencies upfront, then you don't have to put those dependencies. The purpose of your Docker that Docker image that you are building is to download some source code, build some application. Then why not start with the base image that is Maven based?
Okay, so with this, I have just one question and then I'll just end my question session. So, what is the best tip you can give for us to select the base image for a Docker while creating a file?
Because you know what the Docker image is going to do, what that process is going to do later on. Based on that, you will select your base image.
Okay, so if it's Java, so we can use Java as a base image. If it's Node.js, so we can use Node.js as our base image.
Exactly. If it's a Node.js application you are going to build, use that Node.js. If you are going to build a Java application with the Gradle or Maven, you select different images. So that sort of thing. So depending upon what you are going to do with that image, you will be using the right image, base image. That's what we do, right? We not only in this Docker, but everywhere this concept applies. You are building AWS base image, like you are creating AMIs for your company. You will select a relevant base image that AWS provides, and your company says, we use McAfee antivirus, we use CloudWatch agent for monitoring. So install these packages also on top of it, or you bring your antivirus, bring your Splunk agent, whatever agents your company uses. So you will take basic base image from AWS, add and it becomes now your company's image. Same concept apply in Docker also. Whatever you are planning to work on, you will use that relevant base image.
All that, got it, sir. Thank you so much.
But again, it's very tricky. Different base images, you get, like, there is a competition. There is a base image for different versions, base image of different sizes available. So try to play around, choose the lightweight one.
Sanjeev, I have a question.
Yep.
We are building a Docker file. Okay, suppose we have one Docker file, and in suppose we have 9 to 10 lines. Okay, and then we are converting this into multi-stage Docker file. Might be that difference will be only 1 or 2 lines, right?
Right.
So what is the technical, like what is the logic behind that we get the smaller size of the image? If every layer, every like step have each cache layer. So can you help me up with that?
So what I have seen, for example, you are building a Java application. Now you want to use another base image, which is Maven based base image, to build that Java application. But when you are going to ship that Docker image, you don't want Maven to be available there, right? You want to make it lightweight. You want to use that Maven package to build your source code. So you will start with using a Maven based base image, copy your Java application source code to that image, build that, you get a jar file, war file, whatever is that case. Now you take another base image, which is a Java runtime kind of thing. It's another lightweight image as a base image, and you don't need now Maven to build that. Your package is already built by some image. So now you use another lightweight image where you copy your jar file only, not your source code. You don't need Maven also there. You copy your jar file there. And that's how you just run that file, whatever your entry point, or you want to expose that on port 80. So that sort of thing. So now you need only.
But Sanjeev, like if we need a single base image, if we required single, in that case also we observe that like in if we formatted the Docker file in a multi-stage format, then we get the less space. If we require a single base image, even.
Right. Yes, it will be single base image.
That, like you are saying now, if we don't require the main base image, then we are using the from that build as an alias, and we are calling this in the next stage. Okay, but suppose if we don't need any other base image, like we need just simple base image, even in that case also, if we formatted the same Docker file in a multi-stage format, then we get the lesser space of the Docker image. Like,
I am not sure what the question is, or you asked.
I will capture some scenario, then I will show you that.
Yeah. So are you saying that people use they use the same base image in both these stages?
No, not the stage. You said that like there will be requirement of the two base images. So instead of calling the,
I'm not saying it's a requirement. I'm saying you want to reduce the size of your final image. You don't want to ship a final image that has source code or Maven and that as a base image. So that sort of thing you can do.
Okay. I will come up with some examples, then I will show you.
Okay. Just show some like what Docker, and we will try to explain if we know. A lot of people other than me also there, so they can explain. That's why Docker is just these few concepts that we have to understand. That's it.
So Pradeep, there are two methods. Either you can create single image with from the top to bottom all the steps in one image.
Right.
Okay.
Or you can divide these steps in two parts. Like in one image, you are doing all the activities to create the jar files. Once the jar file is created, then take in another step, take the base. Base means the minimum smallest jar Docker image and copy your jar file into that. So your size will be reduced. Like
yes,
Alpine.
But
yes.
Sir, my question is that like we are doing the similar steps if we compare the both files, but how the Docker handling this in background, like
okay,
what is the way
so
of Docker?
You want to understand how the Docker. So actually Docker is a stage-based procedural. So it runs in the step by step. So like you have 1 to 10 step in your Docker file. Okay. So 1 to 9 step you did in first part, and 10th step you are doing the second part.
Okay.
So this works like a stack. So first also from the first stack, it will take only the last plate. Last split means your jar file. 9th step only.
Okay.
Other 8 step, it will remain with the first part only. The
Sir,
9th
you
part
mean that we are
copy in
building
the
2 layers, 2 cache layers in that multi-stage?
no. So first part there will be 9 stages, 9 cache
Okay.
layers, and second
Okay.
it will be 1. But
One.
from first you are copying only the 9th cache,
Okay. Okay.
not all the caches. So
Okay.
actually Docker works in this way. Like first step, it will create this image, and from that image it will create container. On top of that container, it will run the second step. Then it will create again another image, and it will create container. Then on that container, it will run the third step. Then again it will create. So this is internal process I am telling you. So every
Okay,
time it is creating, with each step it is creating image and container. So at the 9th step, it will create the image and container, and that container you are running the 10th step.
Okay.
So this is internal architecture. For each stage, it is creating internal Docker image as well as container, but it is keep destroying as well.
Okay. Okay.
Yeah. Pretty much in old days, I don't know, in my .NET development, we develop an executable or a library that has to be distributed as a debug version, and then there is a release version, which will be
Yes.
lightweight, will not have debug information. So that kind of thing. You have different version for debugging developers to use, and then a different version for releasing, which will be lightweight. Copy, mute. All right. We decided last.
Hello, good evening, sir.
Yeah, hi,
This
Nitin.
side. How are you, sir?
Yeah, I'm good. How are you?
I'm good, sir.
You are not at
Sir,
public place, then can you come on camera?
no, sir. Right now, I'm not able to go.
Everybody is
Actually,
joining from a street, or where are you guys joining from? Why you are not in a room or somewhere?
sir, I'm facing a problem that whenever I'm just getting into any Docker or any in Kubernetes, when I enter any like Docker or Kubernetes cluster node, and in that I enter in the running any command in there. So when it restart, and again when I'm trying to reinstall or rerun that command, it will automatically not showing that command. Like I have to install again and again the same command or installation. Like I am installing systemctl in apt-get.
Why are you getting into worker node, by the way? Why do you have to log into worker node?
I'm checking the service of web server Apache 2, whether it is running or not running in a container or pod. So whenever I enter in a pod, for checking, like I have to install some commands to check that, and when I log out or exit that container or pod, then again I have, when again I'm logging into it, again I have to reinstall that command.
Yeah, Nitesh. So
Yes.
actually, whenever you are creating container from the image is same. So in that image, you are not recreating. So once the container is created, you are installing some software. But after installing software from container, you are not creating new image. So how this will come in the base image? Base image is still same. There are no softwares which you are installing. So if you want the new software should be available next time, then create the new image from the container itself and use that image. Then it will show you the installed commands.
So in a Docker image, I like Docker file, I have to install that commands.
No, not Docker
No,
file.
in Docker.
Once
you,
once container started and in container you installed something, right? Then do the
Okay.
Docker commit that container. It will create a new image.
Okay. I
But
have
better to, if you need something in your Docker image, make sure your Docker file has that, and then you are coming from there. Usually we log into a Docker or pod or a container to debug something, but if it needs long-term fix, then it's via Docker image and building a new image basically.
Okay. So it will not work like that. Like
No, it will not.
any. Okay.
It will not work because base image is still same. In base image, there is no new software.
Correct.
Okay,
So
so
you
if
need to create the new image. Either
So
use create image through Docker file update, or you can do the Docker commit to create the new image from the running container.
Okay, I got it.
But how will that help, Pradeep? Like, for example, he's using in his Kubernetes cluster manifest file, he has specified a specific version. So how will
No,
creating
so actually he just want to understand, like we have one base image,
right,
and as per our company requirement, I have installed 10 new software in that image.
right.
So from that running container, I can save container like commit, then it will create a new image. From that image, if I will create a new container, those software will be already there.
In that case, it will be there. But still, I would suggest follow the approach of updating your Docker file if you have to run something of this sort.
Yeah, ideally, yes,
Yeah.
I agree. This always should be created from the Docker file. But if we still, like someone has shared the container and he is not shared the steps, you are not aware what are all the things installed and how he has installed, and you want to keep that image forever, then you can do the Docker commit.
Sure.
In that case, no need to ask anything what software you have installed, what are all the things you have configured. Yeah. You will get all the configuration, you will get all the software, you will get image ready.
And like one more question I have, there are n numbers of containers and n numbers of application running in my cluster. And I want to know that they are communicating with each other or not. How I will check that?
I'm not clear your question. Can you repeat once?
Like
all the applications within the content cluster, how they will communicate?
Yes, like within a cluster, there are n number of nodes running. And in that n number of nodes, there are n number of application and databases are running.
Within cluster, you can use cluster IP. Cluster IP service. You can use, all the containers can communicate each other. Outside the cluster,
how will I check that they are communicating with each other or not?
Are we getting into monitoring side of it?
No. Just I want to confirm that my data is going to the database through the application, or that I have to ping like in a virtual machine. What we do, like in EC2, when we create a number of EC2 instances, and I have 2 applications running on that, and 2 databases are running. So we ping those 2 applications with each other to check. So how in this Kubernetes cluster we check that they are communicating with each other? So that is my question.
I got your question, Nitesh. So if you want to check the communication within the cluster, so if you have one node, you can use node IP, or if you have multiple node, then you can connect with node IP. Node have the specific IP, and if you have multiple nodes on those node, then you can connect through node IP.
Applications are running on containers.
Yeah, pods. So pod will have
pod.
Will have a unique IP. With that pod IP, you can communicate. Like in one node, you have one pod, and another node, you have another pod. Both pod will have separate IP.
So what will be the command and how will I check
Curl,
that?
you can just direct ping the IP of the another node or pod. Directly you can ping.
See,
Pod IP you can ping
my
from
suggestion
anywhere
would be,
within the cluster.
yes, you can do this, the IP based ping and those sort of thing internally. Might be
Yeah, but
possible.
always use service.
Use service. That's how you should use. There is no need for pod to pod communication directly over IP, because that IP, that pod, that container is short-lived. It can go away anytime, and new IP will be created, new pod will be created, new containers will be created, and your
Yes.
communication will break. So you should be using the service. That's why both these Pet Clinic and MySQL, we will be creating a service. That's how they will connect, and it will be a static endpoint. So something like service dot MySQL in your environment. And if some pod behind the scene dies, service will still ensure that it will bring the container. Until then, one or two containers will serve your applications. And the third one comes, then all three will start serving. So it will ensure health checks and a lot of other benefits.
I have another question related to this. Suppose I have two applications, two separate pods are running, and I am running one service for both the pods. So how can, and I am using load balancer. So how will I know that which service I can access? So the application name should be there after load balancer, or how we can map? Or we can use through ports. Like one app is running on 80 port, another app is running on
IP
90.
is assigned at port level, right?
Yes.
So if there are multiple containers running, they will have the same IP address. So you will have to use ports and differentiate if you are running two services.
But on load balancer also, after suppose I have used service, in service I am using load balancer. Okay, and behind the load balancer there are two applications running. So
Ideally,
how the
this sounds like a unique use case where you will be separating those. First of all, usually you would, because these are two microservices basically.
Yes.
Right. So looks like straight away use case for using, separating them basically.
Like, sir, can we assign a port to the containers for accessing them through the load balancers?
Yes.
Is that possible?
Yes.
And like we have n numbers of container running and n numbers of application, and we have a single load balancer. So how we will access them? What is the way to access them?
Different ports. So you will have
like when we hit the URL, we have to define the port number.
Yes. You will be exposing that application on a specific port number that you want to use. That should flow all the way to your container, and that's how the connectivity will be. You would have used, right? Within the same cluster, you use ArgoCD on port 80, Prometheus, Grafana on different ports, but you can use the same endpoint if you want to, but different ports.
Actually, we did in Minikube. So in Minikube, for each port, we did the port forwarding.
Port forwarding, yes.
Yeah, but now we are doing an EKS. So in EKS, port forwarding is not required because we are using load balancer. In case of load balancer, no port forwarding required.
But concept is same, right?
Yes. So we can give the port after that. Load balancer, then port.
Right. Otherwise, your cluster will be very limited in nature. Like if you have limited, you can expose as many.
Only I was thinking if I will create different load balancer for each service, then there is no point.
Yeah, no point. Correct. Then it's a mess.
Yeah, if I will have 100 applications, then unnecessary I have to resolve 100 host names.
Correct, and maybe the cost will go massive.
Yeah, cost will go high. Yes.
But yeah, that's why I suggested people who finished their project or this part of the project last time, try to experiment having MySQL and service inside the same pod, right? I mentioned that ideally they are candidate for different service, but in this case, the database endpoint we do not have to expose to our customers. That is an internal point. So we can use in the same pod also. So just try that piece also, like what changes you have to make to your manifest file if you believe that your pet clinic UI and database are in the same, not in the same container, in the same pod. Then you can connect it slightly differently. So experiment with that and see if you can come up with.
Sir, I have created a Docker file. In that, I have used PHP 7.4 and some modules of PHP in that file. And I have created that image. And I have used that image to deploy it in cluster. So it is successfully running. My application is successfully running. But
where does
when
PHP come into picture?
Sorry?
Where does PHP come into picture in this project?
No, sir, not in this project. I have experimented a project other than this.
Okay.
So what I have done is I have connected it with the MySQL.
Okay.
Try to
It's
connect.
running where?
But my application is running into a cluster.
But your
And
MySQL is running where? That you need to clarify.
Yeah. So my
SQL
SQL
is
is
also running in another pod.
Another pod.
Okay.
And everything is fine. We have installed the PHP modules also in that, but we are not able to connect the application with the MySQL database. It's showing me an error.
Okay.
So we are not able to rectify that. How, if there is any error is coming, then how we will rectify that error in Kubernetes?
It will not be specific error saying that, yes, this is the issue. The error would be not able to connect with that endpoint, some sort of access denied 404. That sort of information is what you have to,
Like I can tell you the error right now.
You don't tell me right now. Tell it in the group or in when we are debugging this. So people have highlighted, look at the repository, look at the public repository that has been shared by so many people. So look at what that string they use. So there were some specific in the demo people mentioned that how they have created that complete service endpoint that they are connecting to.
Yeah. Actually, it is showing MySQLi error. So that is a module of PHP. I have already installed. Yes, but that is used to connect the database actually. But when I like connecting and checking, it is there in my container already present, but it is not working. Now, like this type of when we are facing some issues, how we will rectify in a Kubernetes?
This is very basic. If your pods are running, you will get into so many type of issues. Your pods will keep starting automatically. Your containers will starting. They get into that recursive process. A lot of other issues are there. Kubernetes is popular, but it's very difficult to manage, right? It's not straightforward. That's why people try to study.
Like virtual machine, we can reinstall the modules, we can rectify the error, we can add it, but in Kubernetes, there is like
with experience, you will know that what could be the possibilities. I mentioned last time that there are 2 or 3 possibilities usually that I have seen. Your sometimes, in this case, obviously that is not the case. Sometimes your containers will not start. They will be in the pending state. A lot of times I have seen that they are waiting for another container to come into a specific state. There are not enough compute resources. Your Docker image that you have built is not stable and that automatically restarts. So those sort of issues will be there, which are very common. But in this case, it sounds more like a network issue, or more like using the right endpoint of your microservice that the other microservice can use to consume. And there were some demos, or some in last demo, people mentioned that how they resolved it.
Okay, sir. Okay.
And this is the right question. This kind of question, you can put a snapshot, or you can put your Git repository and ask that, yes, I have done this. I have a container running. Both my containers are running, but they are not able to connect. Most likely, you need a better endpoint of that service. That's it. There could be other issues, but start with that.
Hello, sir. Should we create two containers in a single pod, that one for a Spring app, and another one is for a database? Is
Ideally not. Ideally not. That is, if you are able to do it in two different pods. First, you try that. Look at my presentation. Look at last week's video, that how that structure is created. Right. First, try the standard stuff. Then once you are comfortable, you have time, then you get into that advanced stuff, that can I have them in the same pod? How auto-scaling will work in that case. Right? You remember we had that orange color graph, and
because we are not explore the database from the outside. So
yeah, we'll fix that issue. It's not that they are not able to connect, means that Kubernetes does not allow that. It's somewhere we have misconfigured it. So we need to fix that issue. I'm not sure what screen. Do you see something on?
Yes.
Yes, Sanjeev, we are able to see your screen.
Yeah. This is what we wanted to build, right? The logical view of our application. This is what we needed to build: a service for our front-end pods, which is Pet Clinic app, and oh no, subtitle started. And then another service for our database pods, and then connect that through those three environment variables that we were talking about, that you will pass. And then once you are comfortable, then you try, can we put UI and DB container in same pod? And what changes you have to make. So you can do that later on. The only because these are two different services, they are good candidate for separating them, but just an edge case or extension to your project, you can try that.
Okay. Okay.
Ask these kind of specific questions instead of saying that we are not able to start, or we are stuck, or it's very difficult, or it's very easy, or that sort of thing, or it's not valuable, or it's not useful. So build something, ask relevant questions within AKS, EKS groups, or within that main group, that I'm using this environment, I'm using Minikube. This is my repository. Can someone take a look? And I have seen people helping each other resolving, and especially people, if somebody has advanced and they have finished that that stage, then obviously they don't want to spend a lot of time every day on that. So try to agree on a time where you guys can meet, maybe for 30 minutes, and ask these kind of specific questions, that how did you resolve this issue, that kind of thing, instead of plain which nobody can answer, which nobody can look into. Keep using that group, like, okay, what is the difference between this Docker file and this Docker file, this multi-stage and the other Docker file. So we do discuss stuff that is not relevant to the project also, like, so any questions you have which is not directly related to it, or you have some improvement ideas, you just keep discussing in that group, but bring something specific that this is the issue or this is the scenario that I'm facing. Generic things, nobody can look into that. Okay, we have spent 1 hour on this, I think. How do we? I wanted to talk about monitoring and other stuff, and should we start into that part?
Yes, sir.
Yeah, let's take a couple of minutes. I'll grab some water and then we can start.
Okay. Okay.
Yeah, hi. So this last part or last stage of the project is slightly standard stuff. Like it's it's used by a lot of companies. There are 2 or 3 options that people use for monitoring. So like somebody said, how do we monitor a service is talking to another service? So I think that question goes into once you are trying to set up your service as a developer, you will ensure that there is a connectivity. But another day 2 operation is that now you have deployed your services, something goes wrong in your environment. Because these containers are being created, deleted based on the load and your scaling policies. They are going from one node to another node because Kubernetes is trying to balance between different nodes. So a lot of things is happening. It's a dynamic environment. It's not like standard fixed EC2 instances or your on-premise environment. So it's dynamic. A lot of things are happening. So you would want to monitor whether some services are talking to another service on a day 2 operation as well. So how does that happen? That is through some sort of observability through monitoring. There are few products. What I have found is you will be seeing Prometheus and Grafana being the de facto standard for monitoring, which means pretty much everyone is using that. They are open source. You don't have to spend so much on licensing and all, but it's an open source product. You get limited support, and people who want to experiment with industry level products, they can or something which is a commercial product. I found Dynatrace actively used by organizations, so you can try using a free license or free trial of Dynatrace also. So this is also something which can add value to your resume, because pretty much just like Jenkins, right? Everybody will say, yes, we have monitored or I have set up monitoring using Prometheus and Grafana. So try to see if you can experiment with this also. So how specifically Prometheus and Grafana works is that Prometheus is more of it can extract a lot of information, connect with the Kubernetes cluster, and collect a lot of metrics data, which is metrics could be your CPU, RAM, and those sort of things. It can pull that information, but it needs to run somewhere. So it can run either in the same cluster or it can run in another cluster as well. So it all depends how you want to set it up. So for our, obviously for this environment, we'll try to set it up in the same Kubernetes cluster. It's again another microservice runs in the Kubernetes. But the only thing is that it needs some sort of persistent volume claim. So you will need to have your same cluster you can use, because we anyway use that. But in case you are doing this part alone, then you have to set up persistent volume claim and storage class and all that stuff as well. And then Grafana has the capability that it can connect to multiple data sources, different types of systems it can connect, and it can help you visualize that information. Prometheus is just one of that data source that Grafana can connect to. It can connect to your MySQL, it can connect to MongoDB, it can connect to a lot of things that I have seen. It can connect with such different systems and can give you or help you visualize that information. I found, this was from last week. I found this graphic online, so I thought I'll bring it here. So in this, basically, Prometheus in the middle is talking to Kubernetes API, talking to Kubernetes nodes, all this behind the scene. We don't have to get into the complexity of how it does that sort of thing. You need to ensure that it's deployed with the appropriate rights, and it can connect with these systems and pull metrics. Fluentd, Redis, and all other systems that are meant in the center, they are more for completeness. We don't use this center part in our project. And then Grafana can connect with Prometheus server using the standard that we talked, right? Again, Grafana can be installed in the same Kubernetes cluster, but on a different port. And then it can talk to the Prometheus server and start getting those metrics, and will basically start showing you what sort of health and how your Kubernetes cluster is behaving and monitoring for that. And then there is another component, which is Alert Manager. You can use it to send messages to Slack, email, or any other webhook you want to. Could be creating a Jira ticket or any other use case. So how will we do this? So I have tried to bring some links from online sources that I think will be helpful to build this part of the project. So if you are doing it locally, you can try to install in your Minikube or as an external system also. You can try to install Prometheus and Grafana as external Docker images if you want, or you can install it inside the Minikube. So you can follow these steps, but there may be additional steps required once you go, detail into this one. I have not tried all these steps. They are taken from online sources, but most likely they should be relatively much easier, because what we found in the when we are setting up MySQL and Pet Clinic, we found that you don't have to create storage class and all that in the Docker when you are using it on your machine. So all those things are out of the box. It's when you try to deploy it in EKS or AKS, then that storage class has to be configured in advance. So these are the two pages that from the AWS that I found are definitely required to be followed in the sequence. And after that, you have these commands where you can install Prometheus and Grafana using Helm chart. So then you follow this. First, we need to follow this first user guide and second user guide, which is basically trying to set up storage class. If you have done MySQL or part 2 of the project, then this line is basically already done and dusted for you, so you don't have to do. If you are creating just Prometheus and Grafana POC, then you need to do this. This is basically the setting up of the storage class. Once the storage class is configured, then you have Prometheus setup, and then you have Grafana setup. You can do it in the same stuff. And what happens is, for example, you use port forward or you use load balancer, doesn't matter. You can log into your Grafana interface on, say, port 3000, and then give the URL of Prometheus. And down below on this screen, you will have a user ID and password to do a basic authentication, and that's how it will start showing you some of the, like, most of the information about your cluster. So these are some of the things we need to try this week. And depending upon where you are, if you are going to be using the Azure platform, then these steps are going to be similar for Azure. These steps, because they are cloud provider specific, these are going to be slightly different. You need to search for a page where Microsoft documents how you can add storage class to the AKS cluster, and then similar sort of monitoring how it helps. So even you can take reference from here when you are setting up, but it's just the storage class is entirely different in Azure, so it will not work with these steps. And yeah, these Prometheus and Grafana, a lot of online sources. The only thing I didn't bring, I don't want to bring a specific demo of that, or because there are a lot of resources available for this kind of use case, and depending upon which kind of so Prometheus and Grafana is actively used. A lot of people have downloaded their so for example, people will want to have their own logo installed in Grafana, so they will download the basic Helm chart that is being delivered by the community, because it's open source, and they will then make some enhancements on top of it. They will add something, and then they will just like Docker images, you have Nginx available, you have Prometheus and Grafana charts available from different organizations, from different community, from different people, different sort of enthusiasts. They publish their version. So depending upon what you are following, the instructions and the Helm chart and things may be slightly different. That's why these are standard some stuff for one use case. But if you are following another article, they may not be using this Helm chart. They may be using a Helm chart given by another company or another enthusiast. Or you can also do that. You can release your own after making some changes. You can release your own Helm chart if you want to. So that's why these things will vary from where you are reading from, for which version of the setup you are trying to do. But these are coming from the official community that releases these Helm charts. So I have taken from the standard stuff, but you may see different commands and different steps to do that. It's pretty much like Nginx. Nginx has a Docker image released by the Nginx organization. Nginx shows a default page when you start your application on port 8080 or whatever, wherever you are serving the traffic. But you can then later on modify that index.html, and you can enhance, add your logo, add your other stuff. So that kind of customization you can do. And then people can release that as Nginx, my Nginx, or a different image name. That same sort of concept applies here. There are multiple Prometheus and Grafana Helm charts available, and we can use Helm charts to deploy that. So try it out in the environment and try to connect Prometheus over with Grafana. But after that, usually in the discussion, the questions are like, but what are we monitoring in this? What sort of information we should be looking in the dashboard, and is that dashboard providing that information? So we have to understand that these are some sort of different layers, and we need to be able to understand at what layer we should be investigating that kind of thing. So for example, connectivity between containers may not be required because they are connected through 6 services. So services are running at pods are being exposed as service. So the services are to be monitored. So that kind of thing. Container, they keep restarting. They are not healthy. So you would want to monitor that for a container. So, but what do we monitor at cluster? You will be monitoring something at cluster level, something at node level, something at pod level, and something at container level. And then because they use this shared service, which is the storage, which is shared by node 1 and node 2. So you would want to monitor the storage also. If AWS and these, they allow you extensible storage, but you would still want to monitor that you are not consuming the entire storage. So there are different metrics available at a different level. So at cluster level, you would, CPU memory is something common which you would be monitoring pretty much at all levels, but the aggregation will be applied. So at cluster level, you will say the CPU level or CPU and memory utilization of the entire cluster, how does it look like? If you have allocated T2 medium or 2 T2 mediums, then is the entire RAM and CPU being consumed? The storage of the entire cluster that you have, the API server latency. You remember that API server and the scheduler and everything is provided by AWS, but it's a software. Even there could be issues with the AWS services. So the Prometheus captures all this information. It connects, if you saw the previous diagram, Prometheus also connects with the Kubernetes API and also with your Kubernetes nodes. So it can help you identify issues with the AWS provided services as well, if there are latency issues, some issues. So because that's the brain of your cluster, so it needs to respond in that appropriate time so that other services can work together, because services are dependent on each other. A service starts, you can configure a service to start once a specific other service has started and given a health check. So in such cases, you need API server to respond in a certain amount of time. Then you can monitor application specific metrics, which is the error rates, 504 errors, latencies, and that kind of thing. Your response rate of your API, your microservices is within the range or not. Do you see a spike or anything of that sort? What are the number of nodes you have in the cluster, and what's their status? Are they connected? They're healthy. Some of this information is also available in the EKS health, that cluster page also, that how many nodes are there, are they healthy or not. But since you are adding another monitoring system, you should have that sort of information there also. Centralized logging is also, we have seen a lot of organizations, they prefer, because these containers are not long running. So what happened to a container which was created 10 days ago, which lasted for say 10 minutes and then was destroyed? So you would want to capture that log somewhere of that container also. So in that case, you need some sort of central logging that can be implemented, not in this solution, but that should be also monitored at cluster level. At different worker node level, CPU memory will be monitored. There will be the disk associated with each worker node that has to be monitored. The node status has to be monitored, the node health, and the traffic, network traffic between nodes and between your control plane and data plane, your worker node and control plane has to be monitored. All these monitoring graphs and everything will be shown in the Grafana. Then at pod level, obviously the pod CPU and memory, you define certain limits in the manifest file, in the deployments that you do. What is the restart rate for a specific pod? Are they frequently restarting? Are they healthy? Do they live for how long they stay stable for? That sort of thing. Network monitoring, the status, and the pod readiness. Are they in starting state, ready state, and that sort of thing. Sometimes pods are held like they will respond that, you know, there are these many pods, but they are in a specific state which is not useful. So their readiness status and the request limits, they are not reaching any of the targets that you have set up. Remember, we can set up that every pod and container to use this much of CPU and this much of RAM. So you can define those limits and they shouldn't be breaching that. At a container level, you will have different metrics. Mainly, you will be looking at their stability, the CPU memory that they are not breaching, how long they are staying up, and what sort of errors they are producing. So the error rates, basically. Error rates are usually like, you do keep an eye on that, because the error rates means either the application is not stable, there are issues with the application itself, or your container is not built properly. So those are the sort of things that you would monitor at different levels in your cluster. And all these things will show up in the, this was an old slide. Yeah. These are the sort of information that we will look for in the cluster. And when we try to integrate them, we will see that this information shows up on the Grafana dashboard once you integrate them, following these steps. So give it a try. So try to implement this piece of project, this stage in the project, and we will see what sort of information do we get. It's very standard stuff. Try it with Dynatrace if you want to, but give it a try on both these solutions. And yeah, that's pretty much I wanted to discuss on this specific topic. Depending on which environment, whether you are using Minikube or EKS, AKS, try these steps. Saurabh, you want to add something that people can try?
I think, yeah, I think the way that the most easiest way to actually put on is through the Docker. So if you don't want to do through EKS, that's the easiest way to install both Grafana and Prometheus. And then you can connect into pods. So I think the way that you explained it, so you can have internal metrics of the pods as well as you can get it from the Kubernetes sources as well. So Prometheus is more like a scraper. So you can either send the metrics traces to Prometheus from an external source, or Prometheus has got its scrapers where it can go inside the pods and it can go inside the cluster and then collect all the metrics. So you can have it both ways. So I think just give it a try, and yeah, probably if there are any questions, then we are here to help.
I know
there are a few advanced things called nowadays. Many organizations are also using OpenTelemetry. So OpenTelemetry is something which is pretty standard, where you have got all these clusters and the external sources, and then they can send the data to OpenTelemetry collectors, and then OpenTelemetry will send it to Prometheus or Grafana. But that is very highly advanced, and it's the latest in the market at the moment. So if you want to give it a shot, just have a read more about OpenTelemetry. But yeah, start up with Prometheus and Grafana first. Yep, that's it from me, Sanjeev.
Yeah, thanks, Saurabh. So yeah, this is, as I mentioned, is slightly standard stuff, but people usually they will see that, yes, they have integrated these two systems, and what next? How do they look at the graph? What sort of information you are getting out of it? Let's try to see if we can simulate. I will try to do this as well. Try to, maybe we will get rid of certain pods. We will delete a specific node and see if our dashboard reflects the exact status of our system, and can we generate some alert from it. That is the basic use case for this week. I know there probably won't be much source code involved in this. It's more of integration, etc. It's not that you have to create Docker files and stuff like that. It's more of integrating systems. Any questions anyone has?
Yeah, Sanjeev, I have one question, not related to today's session, but I just wanted to know.
Can we park it if it is not related to this one?
Sure. Okay.
Or is it related to monitoring or anything?
No, it's not.
Okay, just give me 2 minutes. Let's close this subject, then we will
Sure.
move on to that.
Okay.
Thanks. Anything about monitoring or something that they are using in their company, which is...
Hello.
Yeah.
Sir, I just want to ask the one question: how to integrate our Prometheus with our project?
Yeah. So basic thing is, first, I would suggest you try to do it in your cluster itself. That would be the easiest option. The other option would be that the Prometheus, you will have to make available the kube config, and you will have to, basically, it can reach to your cluster the same way you connect to your cluster through kubectl, so that it can make those specific metric requests and get that information from cluster. But I would still suggest go with the simplest approach for now. Install it within the same cluster.
So just to add to it, so when you have installed Prometheus in the same cluster, so it will have access to all the different pods within the cluster. So what it will do is it will start scraping up all the different nodes by itself, and then it will show you all the different pods which are running. So you will find your pod, which is your application pod within the metrics itself. So that way, your application, which is running in the pod, so that metrics will be captured by Prometheus. So does that answer your question?
Okay. Yes.
Okay. All right. Any more questions on this?
Give it a try. Make some progress on this. As I mentioned, slightly standard stuff you get out of the box using these tools. So try these things. Even with Dynatrace, you get same sort of similar dashboard, just like the Kubernetes dashboard. You will see that a lot of information that you are getting on Grafana dashboard, or even in the licensed Dynatrace product, you are getting on the EKS and AKS site itself. Just that it's difficult to debug. There are different tabs, and people like to use a different external monitoring system that can help in other scenarios.
Sir, I have a question. So is there related to costing side? Is there any way to reduce the cost of using these clusters and nodes in EKS?
Yes, again, through monitoring, it's very useful. So for example, your monitoring system tells you, like we discussed, right? The monitoring at different level, pod, So if your monitoring system tells you that a specific service, say pet clinic, you have defined a pod, that one pod of pet clinic will have one CPU and say 1 GB of RAM available to it. And you find that monitoring system tells you that on an average, 50% of it is not used. So that means you can reduce that image, which will mean that you can actually reduce the size of the node also, if that is the case. These, because at different level, how you aggregate, so these monitoring systems can help you reduce the cost of your EKS cluster. Because you are getting information, the utilization at each layer, and you can try to understand how your traffic pattern is, and based on that you can do that sort of optimization.
Okay, sir.
Because otherwise, if you don't know, right, usually you don't know how much, when you are developing a Docker container, pet clinic for example, or a MySQL, we don't know what should be the ideal size or the minimum requirements for that container to run. So we go with some experiment, we go with a small number, or because if you go really small, then what happens, your containers become very unhealthy. You give it like a quarter of a CPU, and with one single spike in the CPU requirement, if it goes beyond quarter CPU, it will crash. So
like, sir, why I am asking this question, I
you
have some
interview and
like,
it was asked.
no, I have some experience of working on RFPs.
Right.
So while creating the architecture and while creating the costing of any project, we have to like consider the cost of any these resources.
Yeah.
So what is the best way to consider the cost for at that time? Because we don't know like how many resources and what should be the proper CPU utilization and vCPU configurations and RAM configurations. So how we will do that?
So at RFP level, you would go with certain assumptions. You will have to go with a certain idea that how many users are going to access, how many containers you are likely to create. If you have to go with a very firm sort of estimate in your RFP, that I'm giving you a very firm estimate based on certain assumptions, you have to go with that. And you will cover yourself saying that we will put the monitoring system in place, which will give us extra.
Is there any standard method to calculate the cost of these resources?
Yes. So for example, if your analysis says that traffic of the application is pretty consistent, and it needs these many containers, or this is the minimum requirements for one container to run, then you can extrapolate and get a fixed size of your cluster, how many worker nodes you would need. And you will say that, yes, there would be certain variation based on that. It will auto scale itself based on traffic changes. So if traffic changes, then the cost will go up because it will create new resources. But for 10,000 users, you will calculate that one container can take these many user requests with one CPU and 1 GB of RAM. So you need basically do the maths and say that I need 100 containers to run. That will tell you how many worker nodes you need. And if your solution needs high availability, you will say I need the same amount of worker nodes in another AZ. You will double that cost, or whatever formula you apply, then you give that cost.
And plus the exact dollar figure of the cost, there's a service called AWS Calculator you can use. So if you are
Yes, sir, I have used these calculator services, but in calculator service also they are not defining the exact like with the configuration, they are not giving us the exact price for that.
Well, if you're putting up, now this is getting quite complex now, because if you're putting up whether you want it on spot instances or on-demand instances, reserved instances, so it all depends on that, plus what type of CPU are you using? Is it M1 or is it like T3? So as Sanjeev said, you will have to calculate the CPUs used by the containers. Then you will have to check on how many nodes will be running and what sort of CPUs will and memory and EBS, all these different attachments that you will be using. You will be able to get an approximate cost of it. Not AWS doesn't give you a post billing cost anyway, but you will be able to get a ballpark cost using all the resources.
Okay,
So
sir,
there's no cost for running containers. The cost is for the nodes. So it depends on how many nodes you are running.
Okay, sir. Okay.
Okay. Any more questions on that? On monitoring?
Hi, Saurabh, I have one question. I would like to know how Prometheus work internally. Like you said, it is scraping something. Like, is it deploying some agent, or is it communicating with HTTP, some to other nodes? Can you give us the internal behavior of that Prometheus, how it works?
Well, Prometheus has got its endpoints. So if you are supposed to, so what you will have to do is, Prometheus has got its endpoints, and your application should be configuring to those endpoints. So so Prometheus would know at what port to scrape your application. So you'll have to give access to Prometheus for a specific port of the application through which Prometheus will start monitoring it. So that is the way Prometheus starts scraping use and getting access to your application. The other way is that you inside your application, you can put in your Prometheus endpoint and then start sending the metrics to Prometheus. Now, Prometheus metrics, when we're talking about application level metrics, so these are mostly aggregates. For example, like an average of something, a count of something, a minimum or a maximum value. So these are type of metrics that you would be sending to Prometheus. So these are application level metrics. But when you are installing Prometheus inside your cluster, Prometheus also has got access to all the different cluster resources. So then it will start interrogating the cluster on what is the CPU usage, what is the memory it is using, and different sort of metrics inside the cluster itself. So what is the memory node pool, what is the memory of the nodes itself? Is the master cluster healthy? So all these different, so you'll be able to see all these different metrics once you install Prometheus inside your EKS.
Okay, thanks, Saurabh. That helps.
But in like what Saurabh explained, just like at very high level, understand that it's another sort of microservice, and usually how microservices communicate, it will be talking to the API server and getting all that information. What is running? It will have its different protocols that give me all the microservices running, give me all the namespaces that you are running, and then it will start monitoring. Okay, I need the CPU of that particular pod. Then it will have its own protocol to derive a metric which will say that average of CPU over a 1 minute time frame is this 70% or something, which will be see on the Grafana dashboard.
Thanks, Sanjeev.
Same sort of approach with Dynatrace. They will install another service or another microservice that sits in that they have developed proprietary, and that will be installed in your cluster, and that's how it will be able to access all the resources because it will have permissions.
Dynatrace installs an agent inside your cluster.
Any such
but Prometheus is not using any cluster, no? This is communicating via only HTTP endpoints. If we are deploying within that cluster, same cluster where our application are running.
API server.
API server. Okay, API server. Okay.
It will just connect with the API server, ask like, give me all the namespaces, give me all the deployments, and give me all this information on every.
So we don't need to configure it. Like we don't need to tell you need to talk with that node port with that IP or something like that. It will directly, once you deploy within the same cluster, it will start talking with all the node port, all the services we have in that our cluster.
Okay, I think if we visualize it now, it may not be making a lot of sense, but once you start implementing, we will get more idea of how it looks and what sort of information you have to provide at each level. Because, right, for example, we are connecting to a database, we know that we provide an endpoint, database password, stuff like that, and that's how it connects. Okay, so let's try this and see how we can finish this particular stage. Meanwhile, there were some other questions. Sharat, you had some question.
Yeah, one quick question is that can we have two MySQL pods running, or do we need any third-party application to work as a cluster?
Yeah, we saw the other day, right? There were when last week also demo. I think Pradeep or someone, we had 5 pods running for MySQL.
Yeah, what happens is when you have a persistent volume, right, it doesn't run. If you're so when you have a persistent volume, you cannot run 2 MySQL pods. So that's something I was trying to do. So
I thought you demoed this part, yeah, isn't it?
I'm able to do with my persistent volume, and also instead of using GP2, I use EFS,
right?
So which works fine now. So even if the worker
And
node
you
goes
remember
offline,
we terminated some of the pods and we terminated MySQL altogether and recreated the pods, and the database was still persistent.
right? And we had an issue last time when worker node goes offline.
Worker node was
the MySQL doesn't come online because
but
of
we
the AZ
discovered
difference.
But we discovered that was an issue because the new node that was coming was in a different AZ,
right?
And that was not because storage class was not available to that node.
Right. So to tackle that, now I use EFS and use multi-target. So I have created a target point for each and every AZ. So now even if the worker node goes offline, the MySQL pod comes up without any issue. But only thing is I'm not able to run 2 MySQL pods. So that's the only question I had.
What could be the issue?
I'm guessing it's because the MySQL pod that's currently running, or the pod which runs first, right? Probably holding a lock on your EFS, and it's not allowing other pod to hold a lock on the persistent volume. That's what my guess is, but I'm not sure.
Okay. We can take a look.
Sure.
Yeah. That sounds very interesting. That's where it gets interesting and complex.
Right.
Okay. Then we will close the call if no more questions on this topic or anything else. And I hope people will make progress. They will do some hands-on. They will try to, build this, and then we see some more.
Sir, I have a question, sir.
Yes, Aditya.
Sir, I'm getting stuck at some flow of execution, sir. Just like I've installed the Kubernetes cluster, and then ArgoCD I have also installed. But how to containerize the application, sir? I know how to write a Docker file and etc. But the flow of execution, I'm getting stuck, sir. And after installing ArgoCD, sir, what is the next step, sir? Basically.
After installing, I think we discussed this already when we explained.
Yeah. Yeah, I know, sir. But I know after that we had to make the database, the PVC and persistent volume. I know that stuff, but I'm getting confused in containerizing the application, sir. How to containerize to Docker.
So if you are stuck in that part, I would suggest use an existing already created container to start with. So don't be stuck. get a repository for last week's demo and use an existing Docker image from the Docker Hub.
Okay, got it. Sir, is there
That to
any
deploy.
other
So
way?
that,
Is there any way, other way than Docker, sir, to containerize the application, sir?
no, in this project or Kubernetes, there's no other way to containerize or.
Okay, okay. And sir, basically I'm creating the cluster to EC2 instance, sir. So every time I have to reset the cluster, sir. I have to repeat the previous process every time when I am installing my EC2. Then can you suggest me some other way so that I can recreate my cluster, because it's taking a lot of time, sir.
I am not getting your question or.
Sir, basically I am created 3 EC2 instances, sir. 2 worker node and 1 master node, sir. So basically, in every step, sir,
Why are you creating 3 instances and master node? Are you setting up your own cluster or something?
Yeah, I'm setting my own cluster on AWS.
But you can use EKS. You'd never create an EC2 for master node.
Yeah, that's also. But basically, my previous courses and my previous project I have done through this way, so that's why.
That's where the issue is, right? You are trying to set up a native cluster yourself.
Yeah.
And it will be very different from what EKS offers, and there will be a lot of effort setting up that.
Yeah, sir. It
and
requires, I think, 15 to 20 minutes to set up the clusters.
Exactly. So the chances of that getting wrong or is also very high. So what we discussed in the first video, one of the best practices to use an AWS or Azure provided cluster, their managed cluster. So the worker node you will create the worker nodes, but you will not create an EC2 for your master node. That will be managed by AWS and they will charge you for that. So go with that approach, because companies use that approach rather than setting up their native cluster themselves. Even that will take 10-15 minutes because your EC2 instances will come up and get attached to the cluster. There will be a bit of time, but it will be standard process that's followed. And you can use Terraform or something that you can create very quickly and destroy very quickly. All right, then I think we'll close for today, and anyway, we are connected in the WhatsApp group, so let's stay connected there and keep working on this one. Hopefully next week, if people are ready, who have started late or whatever, they can show their demos, show their progress, but try to debug in this entire week itself. Like we won't be able to debug in such a massive group. It's difficult to debug, and we may not get it right also in a short period of time. So let's debug outside of this and come here to ask those specific questions, show some success stories, show it reasonably good demo to everybody. All right. Thank you so much, everyone. Thanks, Saurabh, for joining.
Thank you, sir. Thank you.
Well, thanks, Sanjeev.
Thanks, everyone.